Sam Fall. I'm a college student here at Mount San Jacinto College, and I'm here with Professor Nick Reeves, who teaches biology at the college. And he's going to tell us a little bit about the machine behind us and the program that we're using in it.
So to give you some context for this machine, I just want to tell you a little bit about science, technology, engineering, and math education at Mount San Jacinto College. We're about halfway through a $4.2 million STEM grant, and that grant is providing exceptional opportunities to STEM students at Mount San Jacinto College. Some of the opportunities that we've created for STEM students are by way of a collaboration with other universities. In particular, UC Riverside, which is right up the road, has provided a lot of unique outreach opportunities, including a wind turbine competition that they've been hosting for 4 years. Through that wind turbine competition, our college students have been able to design their very own wind turbine from scratch and test it against wind turbines created by other student teams at our college and at other colleges. We've tried our very hardest to win this thing, but unfortunately we've always come up a little bit short. Now we think we have the key. Now we think we have a slight advantage in this machine. What this machine allows us to do is literally print out 3D designs from a computer. And actually Sam created this wind turbine design last semester for the last wind turbine competition. But this design cost $50 to print, and because of the cost and the time frame, we really were only able to print one design, which didn't allow us to really test out all of the potential options that you guys can come up with. So now that we have our own 3D printing machine, this MakerBot Replicator 2, all of you will be able to design the wind turbines in whatever way you want, make whatever modifications you want, and print them out in just a few hours for just a couple of dollars. This means that this year we're going to be able to prototype many designs and really take very sensitive measurements to see which wind turbine blade design and which wind turbine in general will put out the most power and have the most efficiency. And clearly this is a very innovative approach and something that will definitely add to your skills as an engineer. This is very realistic and very relevant, so it will definitely benefit you.
Get you beyond carving and balsa wood.
Yes.
So in this video we're going to be showing you how to start with the starter blade model and taking it through the different steps to completion, exporting, and finally getting it onto the MakerBot 2 replicator. So we hope you enjoy it, and happy modeling. Alright, this is a video for modeling a basic NACA 4412 starter blade. The end product will be an STL model that should work in most 3D printers, and specifically we'll be printing this on a MakerBot Replicator 2. For this video we'll be using this profile, and this is actually just a rough, relatively imprecise profile that was done with points, and you can do the same thing as this one by just loading in a backdrop and manually point and click and just make the line follow the curve of a pattern that you've gotten in a picture form. Alright, the last things, this is what we'll be actually using. This is a shaft hole, 1/4 inch, for the 1/4 inch dowels that we'll be using as shafts on the blade, and this is the root and the tip. So let me get started by lofting the root and the tip. I will be using the lofted boss base tool. You select the point. I like this one on the edge there because it's nice and clean, and you select them both, and then you hit the little green square. Now one thing I'll let you know, if you want to create your own profiles by importing a background image or something like that, I would go ahead and just modify this basic profile, because the topology that is created using this profile, I did a lot of trial and error to get something that seems to be pretty clean and doesn't cause a lot of problems with the program. It's got this flat section right here, and that seems to work out well. So you might just want to modify this profile when you do that. This loft process that we just saw, let me go in and do an edit. This loft process, using these two profiles, if you wanted to create a more complicated shape, this is actually a very simple straight shape. If you want a more complicated shape, then you would be using these datum planes here in the middle, and let me just I'll just demonstrate it actually. So let's just undo that loft. The process to create intermediate shapes would be to click on the plane and start a sketch, and then you select the space curve, the root, and make sure you select that little line segment, and then you hit convert entity, and that converts it over to here. You hit the little green arrow, and now you can select this converted entity, make sure to get the little line, and under this menu here you can move, rotate, and scale. So let's say we want to scale. We want to, this field, you click into that field, and we're going to scale around the origin. And then right here, we're going to say 0.5. And so you see how that resized it. Hit the green arrow twice, and then let's hit exit sketch. And that created an intermediate profile that we could include in our loft. So if we wanted to loft, we would go loft, click there, and then click to there. And so that is how you would do it. Let's go ahead and undo that. Alright, so now that we've done that, we want to select this end surface here. Make sure you get the whole surface so it turns dark blue like that. And we'll hit dome using the dome tool. Spacebar brings up this orientation menu. Hit top, and then you can just use your mouse's scroll wheel to go up, and you can zoom in and out using that. All right, now you notice how it's it's kind of got the wrong shape there. We want to uncheck continuous dobe, and that gives us a more rounded shape the way we would like. And you can click in here, and you could change this value to another if you want it to come further out. But that looks good. So let's just hit the little green arrow, check mark, and there we go. That's one. The next thing we're going to do is create the chamfer, or fillet, excuse me. Okay. Alright, so we select that edge, and then we select that other edge, the little one, and we use the fillet tool here. Select the small edge, and then we're going to use just a 0.02. And you can see that shows up in yellow, and it's just really for aesthetics, frankly. So we'll go ahead and hit the green check mark, and now we've got that feature. Alright, then the last thing we want to do is create our hole. For that, we're going to do an extruded cut using this feature element and the extruded cut tool. And we're going to reorient a little bit, and we'll just pull it in that direction, and then we're going to go over to the numeric pad here and enter 4.6, and that brings it all the way out to there, and that looks pretty good. So let's go ahead and hit the green check mark, and then that's it. This is the completed basic starter blade. You can use this as a starting point for comparing your data against. So when you create a more complicated, more efficient blade, whether it's got a twist from root to tip, which can help the efficiency quite a bit, or if it's got a different profile along the back edge, or however you sculpt it to increase its efficiency, you can compare it to this base model and do your analysis, and that will show you how much better than the base you did. Alright, the last step is going to be to save it out in STL format, and that's very simple. We just do save as, and down here we choose STL and hit save. And the next step will be to take the STL model and import that into Makerware and set that up in there, and that will be in the next video. So until then, we'll see you then. Hi, my name's Sam Fall. I think I'm a college student. Yes, I'm a college student.
Because they were designed in a computer and printed by a 3D printer, they're very repeatable. I'm really losing it this time. I'm going to stop.
Bloopers.
I know. Blooper reel.
I'll add it to the end, don't worry.